Spiky and Bubbles were playing with their new rainbow-colored slinky spring. They were making waves with the spring when they had a debate. Spiky fixed one end of the spring and moved the other end up and down. He said that this was how you made a wave. Bubbles disagreed. Instead of up and down, she moved her spring back and forth. She claimed that stretching and compressing the spring was the right way to make a wave. So, who's right? Let us first see what waves are. By definition, a wave is a disturbance in a medium that transfers energy from one place to another. A medium is any substance that allows energy to travel through waves. Most waves carry energy and need a medium to travel from one place to another. A medium can be water, air, metal, or anything through which waves can transfer energy. For instance, sound is a wave that requires a medium, such as air, to travel from one place to another. Without a medium, sound cannot travel. Suppose somewhere out in space a huge explosion occurs, but we don't hear anything. Why? Because sound waves do not travel in a vacuum. They need a medium like solid, liquid, or gas to transfer energy. Let's look at Spiky's spring again. First, focus on the hand movement. What do you see? It is moving up and down. Now, look at the whole spring. In which direction is the whole wave traveling? It is moving away from the hand towards the right. The wave direction is perpendicular to the direction of the movement of the hand. A wave in which particles of a medium move up and down perpendicular to the direction of the wave is called a transverse wave. Light waves and vibrations in strings are examples of transverse waves. This bump on top, this highest point on a transverse wave, is called a crest. This bump at the bottom, the lowest point on a transverse wave, is called a trough. Now, let's look at Bubbles' spring. Notice the hand movement. Is it moving up and down? No, it's moving back and forth. Now look at the whole spring and notice the direction of the wave. It is also moving back and forth. Here, the wave direction is the same as that of the hand movement. A wave in which particles of a medium move back and forth, parallel to the direction of the wave, is called a longitudinal wave or a compressional wave. Sound waves are an example of longitudinal waves. In a longitudinal wave, the points where the strings are squashed or compressed together are called compressions. The points where the strings are stretched or spread out are called rarefactions. So, who was right, Spiky or Bubbles? Well, both. Spiky produced transverse waves and Bubbles produced longitudinal waves with their slinky spring. So, we now know that there are two types of waves. 1. Transverse waves. 2. Longitudinal waves. Let's do a quick exercise. If we drop an empty bottle or a plastic ball into a pool of water, it will float on the surface. The bottle or ball will move up and down because the water waves move sideways. The direction of the movement of the bottle or ball is perpendicular to the direction of the water waves. Thus, water waves are transverse waves. Today we've learned that there are two types of waves. 1. A transverse wave is a wave in which particles of a medium move perpendicular to the direction of the wave. Light waves are transverse waves. 2. A longitudinal wave is a wave in which particles of a medium move parallel to the direction of the wave. Sound waves are longitudinal waves.